Hello and welcome back to the lesson 2 in the module 6. The module 6 was about logarithmic functions. The lesson 2 is about properties of logarithms. The learning objectives of this lesson are solve logarithmic equations using properties of equality and to simplify and evaluate expressions by using properties of log. Its logarithm short is log. We just call it log functions or log equations. Now, this is basically the properties of log functions. We will look into the keyword now. It is logarithm equation. So, logarithm equation, you know what is the equation where equal to is there. Now imagine there is 2 log base 3 equals 5x and log base 3 equals 2. This is the equation, okay, logarithmic equation. Now, logarithmic equations have, over here we will see, if you have an equation of logarithm and the bases are same, then whatever is the terms inside log can be equated. In the sense, over here log 3, base is 3 and here also base is 3. Then you can equate x is 7. This is what it means, okay? This property holds true even for inequalities. Now, even if you have inequality sign, you can simplify and you can just consider x is greater than 7. That's what it means. Now, before we go into this logarithmic equations exactly, now we will solve a simple problem which we have solved before in the previous video in the lesson 1. So if you have not yet watched that, please go back, watch it and then come over here. So we had seen in the previous video, if you have say base 4, what do? If you have base 4, you take it over here and this whatever number is there goes up to the power. In the sense, it becomes 4. Sorry, over here what is remaining? X. Log goes, cancels off. 4 comes over here and to the power 5 by 2. This is the answer. Now, here equate it. You can solve it. Now you can change the base. This 2 can be written as, 4 can be written as 2 square multiplied by 5 by 2. And this 2 cancels, you're remaining with 2 to the power 5, which is 32. Otherwise, you can always use your calculator to solve. Now, how do you solve this? From here directly, you can do 4 to the power 5 divided by 2. Calculator gives you the answers directly. There's one more method. You can solve it directly from the question. How is that? Type it as it is. Log base 4 of x alpha x equals alpha equal to, that's by pressing calc, 5 by 2 or 2.5, 5 divided by 2. You need to press shift and solve. Now here I'm getting the answer, but at times you won't have the answer, then you need to press equal to. Now say for example, if I clear the calculator and now I will do this, log base 4 alpha x equals 5 by 2. Shift and solve. You might think, what's wrong? I'm not getting the answer. You need to press equal to after pressing shift and solve. Okay? So if you just press equal to also, it's wrong. You need to press shift, solve, and then equal to, you will get the answer. So that's the answer, 32. This is an easy one. But what about this one? Here you can see the log base 5 and log base 5 equals. So whatever is inside the log function, 2x squared minus 6 equals the right hand side, that is 4x. Now you to simplify this, 2x squared minus 4x, when I bring it to the other side, minus 6 equals 0. Now you need to solve this in calculator. I mean, you can do it by factoring if you've got the patience and time, but since over here you're dealing with log, this is not what you're dealing. I will directly go with calculator method. But if you want the exact method, you can find the videos where I have done about quadratic solving and everything, factoring basically. Now you can go to solve quadratic. This is a quadratic function because it is having the highest degree of 2, x to the power 2. So what you need to do is press mode. 5 is for equation and then press 3. See over here, only 3 is quadratic. Now press the coefficient. X squared coefficient is 2. Then it is minus 4 here. And lastly, we have minus 6. And you can see the answer is 3 and minus 1. X is equal to 3. X is equal to minus 1. you will have two answers. Why? Because it is quadratic, power 2, so you will have two solutions. But now there is a problem. What is the problem? In log, there might be extraneous solution. These both might be the solutions, but there might be a chance where one of this may not be true. So what you need to do is you need to put this value back into the equation and check both the sides, because there are certain restrictions for logarithmic functions. Therefore, what you do is, this is very simple, equate it, find the answer of x. But both may not be the answer. So what you do is go to mode and 1. You'll come back to the computation mode. Here you need to press log base 5 and solve this. 2, instead of x, put the first value, 3 squared minus 6. And what is the answer? It is 1.54. Now do it at the right side as well. Log 5, and over here you need to multiply 4 into 3. Is it the same? Yes, it is the same. So yes, I can 100% tell this is the answer. Let's do the same thing with the other value, x minus 1. So I will do first the right side, okay? Now it is minus 1 negative, so it is error. Why? Because you won't be able to have a log of negative function. It's not possible. So this is the thing. Here you're getting error. That means this does not exist. Let's see the left hand side. You might get the answer over here. See, 2 into negative 1 square. Why? Because this negative sign cancels off, right? It becomes positive. And close the bracket. No, over here also you will get a math error. I just realized it'll be positive, but it's 6 minus 2. 2 minus 6. It'll be negative. You won't get the answer. Okay. So anyone you get, you can just understand this is wrong. You can't have x minus 1 over here. You can see this entire thing becomes minus, which is not in its domain. In the graph, if you look, this value does not exist in its domain. Because it's positive, it will be something like this. If it's 0, will be asymptote over there. There is no values, negative numbers. It does not exist at negative number because it's inverse of exponential. So this is the reason why only x is equal to 3 is the correct answer. Not both the answers. X is equal to 3 is the only correct answer. I hope this is clear. Extraneous solution means there are two possible solutions, but only one might be true. It's like, imagine there are two cars of the same paint, of the same, say two similar cars, same model, same everything, but number plates might be different. So you might be confused with them, right? So actually, which is your car? You need to put your exact key and check, or you can check the owner's name and check. That's just to understand. Two might be there, but only one might be the correct answer. Now then, we will see this one over here. Okay, there is one more way to solve. If there is extraneous solutions, you can directly put this in calculator, because in calculator it only gives you the correct answer. That is, entire thing, log 13 minus 5 alpha x equals log base 13 minus 2x squared plus 3. You need to press shift and solve and press equal to. It'll take some time in the norm. This is a computer simulation, so it'll be quicker, but generally it will take long time at many times. And let's see. Yes, that's the answer. But now let us solve otherwise. So you need to equate minus 5x, that is equal to minus 2x squared plus 3. Here what do? So you need to take this minus, you can take minus 2 and 3 to the other side, or you can take this minus 5 to the other side. It's up to you. I'll just take this right to the left. It'll become positive 2x squared minus 5x minus 3 equals 0. Now mode 5, 3, substitute the coefficients 2, minus 5 and minus 3. Here you will get the values x is equal to 3 and x must be negative 5. That's negative half, that is equal to negative 0.5. Forgot right minus here. Okay. So now what you need to do is you need to substitute these values in this. Now here, just you don't even need to do it. If you put 3 away, it'll be negative 15. So you won't get the answer, isn't it? Now base 13, negative 5 times 3. It's error. Even over here, same thing. 3 squared is 9. 9 times minus 2 is negative 18 plus 3, negative 15. No, it's wrong, okay? It'll be the same thing. But let's try with 0.5. Half, that is negative 0.5. You're getting some answer. This will be the same thing at the right hand side as well. Okay, let me just note down. It's minus 3.357. Okay, negative 2 into square will be negative 0.5. The whole square plus 3. This will be plus 3. And here the answer is negative 0.3572 and so on. It was the same answer. So yes, this is the correct answer. That is negative half. And now we will move on to the properties of one thing. Don't think x. Don't get confused that x can't be negative. X can be negative. It's just that inside this log, this terms can't be negative. That's it. So x can be anything depending on the equations. Now then we will see some properties of log, that is the product property. Whenever you have like this, say you're multiplying two logs, log any number, we 8 is multiplied by 4, okay? You can simplify this. Now base must be the same, okay? Any base, you can take it as any base. If you don't write base, it will be 10. Now here this would be equal to same log 8 plus log 4. You can do this. Let's try. Wait, let's go over here. Even if you don't put base, it's fine, but let's just put a base, say 5 over here. Let me just do this. Log 8 plus log, sorry, this one with the base 5 and log 4. What is the answer? It is 2.15. But now look over here. I will just write inside this multiplied by 4. It will be the same answer, 2.15. You can write with any problems. You will get the same answer. So this is the property of log. And there is a quotient property or division related to division. So this is used to approximate or solve problems. Now here, quotient, it is with negative. So what happens over here? Log, if you have any division, you can write it as that log minus the denominator. Now, why you might have observed in various situations, even with exponentials, exponents, log, multiplication is related to addition and minus is related to division. Why? Because multiplying numbers, 2 multiplied by 5, how much is the answer? 10. Same way you add these two numbers, what is the answer? 7. It becomes bigger, whereas subtraction makes it smaller. 10 minus 2, what's the answer? 8. It's smaller than what we had. 10 divided by 2, it's 5. So it's smaller. So this is one way you can remember. Always when you have multiplication and addition, it's making big, so they are grouped as one. And you know, with the property of multiplication, we add the terms, whereas with division we subtract log terms. Now we will use this to, you know, and also there is one more thing, power of any log. Now if you have log 2 power 5, this can be brought down, that is 5 log 2. Base is not mentioned over here, so we can try this. Log 2 to the power 5 is 1.505, would be same as 5 multiplied by log 2, 1.505. You can try this by yourselves. You can compare both the answers, will and should be same. So now then, how do we solve these problems? Obviously you can directly jump into, you know, now they have given you one answer and they have told you to solve for this. Since you have your calculators, you can directly type it out, you know, log base 3405, because it's log, you can just do it. Okay, the answer would be this. Now otherwise you need to get 205 in terms of base what is given to you, because you can't just see, now this base is there, right? You can't just have any number. You need to have log base 3 phi as well. Sorry, I told base in terms of phi, okay? You need to get in terms of phi so that you can solve and simplify. Over here, what you need to do is get this in terms of multiple of phi and something of power 3. Okay, so this is the thing. Now you can put this in the calculator and you can solve. Okay, this something, what is this power? It'll be 405 must be equal to phi multiplied by 3 to the power x. If you press shift and solve, you'll get over here the answer is 4. Okay, this is one way to solve it. Okay, you can get this is the power, or you can just do by thinking, or you can directly do this by calculator. It's up to you. Now what do you do over here? You need to use the log properties, product property. So when you multiply, you can add them separately. Now look at the bases. 3 and 3 cancels. What's the answer over here? 4. Whenever you have the base and this term same, I think so it was mentioned in the last lesson, it's always just goes off and whatever is the power remains. Why? Because this comes over here and this is equal to 1. If you have, say, log base phi multiplied by phi, it's 1. This is because if we convert this inverse of exponential, if we do in the exponential form, it is easily understood. It was done in the last video. So this is very important to know. Same way, we know the property. What is the property? This 4 comes down, log 3 and 3. So this is equal to 1. So you're remaining with 4. That's why it's 4. Inverse property of exponents and logarithm. And over here, you know the value 1.465, right? Just add over here, answer is 4.65. Or you can directly solve this. Log base 3, 405 will be equal to 1.46. And you know your approximate 3 decimal points is given. So 46 and 49 becomes 5. This is the answer. You can try this by yourselves, or you can just write, you can just solve it by calculator. I will just use the calculator, but the method is known, the method is same, so you can do the method. It'll just take time, or you can just try this. Log 8 and 320. The answer is directly obtained, 2.77. 4 and it becomes 0, okay? Same way over here, you can try this. Now over here, why they have written not equal to and approximate? Because you're just mentioning 3 decimal points, not all the decimal points. You can see log base 3 of phi is equal to 146,649 over here, but you mention it as phi. That's the reason. Okay, I hope this is clear. And now what do? You need to solve for this one. Log 3,9 divided by phi. The answer is 0.535. And here, okay, this is the answer. Because it's 0, you can just use this much. Same way, please do it in the calculator by yourselves and check it. Or if you're enthusiastic enough, you can use this. Okay, one second. I will just tell you over here what is done. Because it's division, right? You write 3 in terms of 3 squared and divide by phi. And then you use the property of log 3 squared phi and then simplify. Yeah, it's mentioned, you solve it. Here also you can get this in terms of 6, you can get it in terms of 6 to the power something, and then you can simplify. And you can just use the power of 6, it might be 4, I guess. 6 to the power, okay, yeah, 6 to the power 4, because 6 to the power 3 is 216 multiplied by 6, you will get this answer. Now you can write this in terms of log 6 phi by 6 to the power 4. Use the property of log 6 phi, log base 6 phi minus log base 6 to the power 4. Here you know the answer is 0.8982 minus this cancels you, it'll be 1, so it'll be 4, and just solve it up, it'll be minus something. Let's do the answer. Log 6 over here phi divided by 1296, and you're getting the answer minus 3101. That's it. That's the answer over here. Over here also it'll be the same thing. Let me just do it. 0.8982 minus 4. Here you go. It's the same answer. So this is how we solve problems. Over here you can see this is how we solve these problems. Now please do it by yourselves. Log 2 1296, and here you go with the answer. There are various methods to solve, but ultimately the final answer is what that matters. Try this as well. Just changing over here. 243, and the answer is 7.92. Let's see. Yes. The last problem in this, a real world problem. It is another, it's a simple problem as well. Now let's see what it means. The loudness of a sound L in decibels is defined by L equals 10 log 10 R, where R is the relative intensity of sound. A choir director wants to determine how many members could sing while maintaining a safe level of sound about 80 decibels. So 80 decibels is a safe level of sound. If one person has a relative intensity of 10 to the power 6 when singing, then how many people could sing with the same relative intensity to achieve a loudness of 80 decibels? What this means is, see, first of all, this equation is important. This equation that is given, L equals 10 log base 10. Sorry, why is it? Okay, L equals 10 log 10 R over here. So this one, R over here, is the relative intensity. Now imagine I'm speaking at a certain intensity. So that is a certain level. It can be measured in different ways. It's given over here. The relative intensity of one person is 10 to the power 6. It's a million. Sorry, 1 into 10 to the power 6. Yeah, it's a million. So this is the relative intensity of one person. But they have also mentioned the safe level of sound, the sound loudness of sound. L is equal to what? 80 decibels. It should be only maximum up to 80 decibels. So L is already given as 80. Okay. 10 log base 10. The relative sound of one person is 10 to the power 6. For one person, it is how much? 10 to the power 6. But the director wants to know how many can sing. X value. X value will be how much? This is what they want, X. Okay. In terms of R, instead of R, they want to know how many people multiplied by 10 to the power 6 can sing when the total loudness must be only 80. I'll repeat this again. L is the loudness of the sound. That you can't have too loud sound. It's not good for ears, and at any certain place you can't exceed certain loudness. So there is a safe level of sound, that is 80 decibels. Okay, here it is 80 decibels, and that is the maximum sound that they can achieve, the choir can achieve. But what is this relative intensity? It's for one person. Now one person is 10 to the power 6. If it is two persons, it will be 2 into 10 to the power 6. So it's 2 million relative intensity. So intensity depends on number of people. So basically you can write X into one person's intensity, so you can find the number of people. Here what they want to know how many people can be used in the choir to reach this 80 decibels. All you need to do is this equation and put it in the calculator. 80 equals 10 log base 10 of unknown value multiplied by 10 to the power 6. Now when you shift and solve, you'll get the answer. You need to press equal to, it's 100 people. So basically 100 members. Okay, you can read this. They have explained it in different ways, but if you understand this concept, that's it. So totally 100 people can be played, used in the choir with the intensity of 10 to the power 6, whereas the total loudness of 100 people with this intensity will be 80, and that is the safe limit. That is fine. So maximum of 100 people can be used in the choir. Choir is like a group of people singing some songs. So that's it. Here there are, okay, you can do a check as well. Check in the sense you should just put this Over here in this equation, put this R value and find for L, it will be 80. That's what is done over here. You can put this R value and substitute and solve. You'll get L as 80 because we had considered 80. So that is the. So that's it for this lesson. It is a very simple lesson on properties of logarithm. You can use calculator at many instances, but the concepts are also crucial. Basic concept is like changing the exponential form from logarithm and logarithm to exponential, which you studied in the last lesson. That is very important. No using calculator over there. Otherwise, if you know the concept, it's fine. There are few properties and calculator can be easily used. That's it for this lesson, and see you all in the next lesson. Bye bye for now.